Hey guys, so isn't this a classic math problem? So in the previous proof we wrote, we had to prove the triangle sum theorem, but we couldn't use it, and so we had to use the exterior angle theorem to kind of create an equation. And on this one, it's just reversed. We want to prove the exterior angle theorem is a true theorem, and so that means we cannot use this fact. We cannot use the exterior angle theorem in our proof. Now, the cool part is that we can actually use the triangle sum theorem now. And so the one theorem that we've been banned from using so far in our proofs is that if I take the three angles of a triangle and I add them together, I get 180 degrees. But I can use that now. Like it's okay, because the only thing I can't use is that if I take the two interior, if I can't use the exterior angle theorem. So I can't use the fact that if I add these two angles together, you can't see that, I get the measure of angle 4, because that's precisely what we're being asked to prove. So we have to get around that. But it really, at this point, it's just about building equations. And so we're afforded something a little bit different here. We're told that the measure of angle 3 plus the measure of angle 4 equals 180. We didn't have to be told that. If you look, that's going to be another linear pair thing, and with supplementary. But since we're given that, like, we don't even have to go that far. We can actually jump right in with the triangle sum theorem. Now, and as far as the analysis goes, okay, one thing hopefully you picked up on is if the target is an equation, it's an equation that we have to build. Okay, which means we need a starting point equation, hopefully involving as many of those angles as possible. And I kind of already gave away the hint of what we're going to do, since we do have this triangle, which I'm going to go ahead and highlight now, not in highlight, but I guess I'm going to outline it in red. That should probably be our starting point. If we have this triangle, we automatically know that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. That's just the triangle sum theorem. Okay? Which is a fact we've known for a while, but now you finally have a way to call it. This should be triangle sum theorem on the left of this proof, I hope. And so that's going to be our starting point equation. We're pretty darn close, because if you notice, this just has 1 and 2. We have 1 and 2 here, but we have to somehow get rid of the 3, and we have to get rid of the 180 and replace it with a 4. But luckily, we have this given information. We're told that the measure of angle 3 plus a measure of angle 4 is equal to 180 degrees, which, again, we didn't have to be told that. I mean, we could have determined that using linear pairs again, but we're just told this, so we can just start here. It seems like we probably need to create a substitution. Like, if we got to get 3 out of here we have 3, because our building equation here doesn't have 3, so we have to get 3 out of there somehow. But if I do some algebraic manipulation on this equation, if I subtract the measure of angle 4 from both sides, I'm left with this equation that just says that the measure of angle 3 equals 180, subtract off the measure of angle 4. Okay? And so if I do the same trick I did in the previous one, where I kind of bring these equations together at the same time, like I substitute out the 3, measure of angle 3, excuse me, in both equations, and I kind of combine them, I should end up with, let's see if I'm doing this right, the measure of angle 1 plus the measure of angle 2, exchange 3 here, plus 180. Let's do it in purple, make this more obvious. And so I'm exchanging out this part for 3, so it should be plus 180 minus measure of angle 4 equals 180. Okay. And so that's kind of a Mondo equation, but if we do some manipulation, right away the 180 should cancel, because it's 1 to either side of the equation, and then I can just add the measure of angle 4 to both sides. Well, we can't see that, but that says measure of angle 4. And so if I shift the angle 4 over here, the final thing I have is angle 1 plus a measure of angle 2 is equal to the measure of angle 4. Which is what I wanted to build. Like, that's actually my real equation up there. And so I have a very similar setup to the one I had in the previous one. And so step 1 here, and I can't use brown, darn it, green. Okay, so step 1 here is establishing this equation using triangle sum theorem. Step 2 is bringing in the given. We could have also just said linear pairs or whatever. And then doing some form of like substitution slash manipulation to build the equation precisely. And so if I look at my statement of intent, like that's what's going on here. So we're going to start with the equation given by the triangle sum theorem, which is this guy. We're going to start with this equation right here. So I kind of messed up, I'll be honest. Like I didn't realize I gave myself the information. And so it's really not this, not using linear pairs. I'm going to use a given information. Okay, and the given equation is this guy right here. Then I'm going to substitute and build the final thing, which I did a substitution kind of right here. And then I had to do some like subtraction or whatever to actually get to the final form. Okay, so again, I think I'm going to forego the 2-column proof here. I'm going to go ahead and write the flow proof again. All right, so like the proof itself, we have the starting equation. There's a measure of angle 1 plus a measure of angle 2 plus a measure of angle 3 is the same as 180 degrees. We know that because of triangle sum theorem. I'm going to abbreviate a little bit. Right. So I'm going to have this separate thought about the given. And so I was told that the measure of angle 3 plus a measure of angle 4 equals 180 degrees, which is just linear pairs and supplementary, but it's okay. And so this was given. I'm going to write that off to this side. I'm going to do a little manipulation here. Okay, that's given. And so if we take this equation and we solve it for 3, in other words, we subtract 4 on both sides, we're left with that the measure of angle 3 is the same as 180, subtract off the measure of angle 4. The justification here is like algebraic solving. Okay, in other words, we're allowed to use our algebra skills to manipulate stuff. Okay. And so that's our second thought. Okay, so if we bring these together, so I take in this red equation, I add to this blue equation. The thing that I want to notice is that measure of angle 3 is the same in both. So we're going to do a substitution. We're going to take out the angle 3 in our red equation, and we're going to put this part in. And so in other words, this is also pink. And so these are all 3 exchangeable equations. And so our final form here, at least our combined form, not our final one, is going to be the measure of angle 1 plus the measure of angle 2. And now I'm going to go ahead and do the substitution part here. So I'm going to take out angle 3, and I'll replace it with plus 180 minus the measure of angle 4. Okay, because that's our exchange. This used to be angle 3, but now it's this guy. Is equal to 180 degrees. And we do have to justify this, so let's go ahead and put in our reason. This is because of substitution. All right. And then we have to do a little manipulation. So we don't have to necessarily show this, but like what's essentially happening, just like I explained it before, is that the 180s here cancel. If I can subtract 180 off both sides of the equation, and end up with, and this is kind of like a medium step here, so measure of angle 1 plus a measure of angle 2 minus a measure of angle 4 is equal to 180 degrees. Okay, and that's just algebra solving again, right? So just canceling it out. And so we take one more step. In other words, if we add measure of angle 4 to both sides, I don't know why I wrote 180 there, guys. That's wrong. Sorry. That's not 180. We cancel 180, so that's actually going to be 0. Okay? So if we add measure of angle 4 to this side too, that means our final equation, because the 4's cancel on this side, will literally say the measure of angle 1 plus a measure of angle 2 is the same as a measure of angle 4. Okay, now the justification for all this right here is just, again, solving. Okay, but we end up with this final form, and that's ultimately what we needed. And so again, we have this proof that's really more of a build calculation, a calculation building. But there you have it. Okay, so again, weird, but not beyond what you guys can do. And so you might have to do this more than once. And that's the thing I probably didn't mention clearly enough. Like one of these proofs, or just doing these proof one time, is not enough. Like in all these proofs that we've done so far, you should definitely like try the same proof again. use your proof as a key, but just, start over from scratch. Do you remember the steps? Do you remember the thinking involved? And that's how you really get good at this stuff, is by just like going over the thinking over and over again, right? So that's that one. I'll see you guys in a moment in the next one.